Fine students, so this is the third problem that we are solving on simplex method. The first two problems we have solved it successfully. So this is the third problem that we are solving LPP using simplex method. So this is what the problem is. So use simplex method to solve. Max z is equal to x1 plus x2 plus 3x3 subjected to these constraints. Fine. So first of all, we have to think that whether the given problem is in standard form or not. If it is not in standard form, we need to convert the given LPP into the standard form. So to do that, rewrite the inequality constraints, that is, these are all the inequality constraints, into equation by adding slack variables. So why we are adding slack variables here is because these constraints are less than or equal to. If any variable or if any constraint is greater than or equal to, then we are going to add surplus variables. Presently, all these constraints are less than or equal to, that's why we are going to add only slack variables. Fine. So after adding slack variables, the LPP will be in a standard form. Fine. So it will be like this. Max z is equal to x1 plus x2 plus 3x3 plus 0s1 plus 0s2. So as there are only two constraints here, so we are adding two slack variables. So subjected to 3x1 2x2 plus x3 plus s1 is equal to 3. Then it is 2x1 plus x2 plus 2x3 plus s2 is equal to 2. And whereas x1 comma x2 comma x3 comma s1 comma s2 are greater than or equal to 0. So by adding these slack variables, now this LPP is in standard form. Then now we are supposed to go for the simplex table. Fine. So the first simplex table will be like this. So it is CB followed by B, then XB, then X1, X2, X3, S1, S2. Fine. This is the simplex table, initial simplex table it is. So presently at first the given LPP is not in a standard form, so we need to make that LPP to the standard form by adding slack variables. When we are going to add slack variables, when the constraints are less than or equal to. If any one of the constraint is greater than or equal to, at that time we are supposed to add surplus variables. Fine. So slack and surplus variables are used to make the given LPP into standard form. So once we got the standard form of an LPP, then we need to represent the LPP in a first initial simplex table. Fine. So this is how it is the first simplex table where fine. So let me write all the values. Fine. So by writing values is also very tricky here. So what are the B means bases? Bases are like S1 and S2 are the bases and their coefficients are 0 here. Then what is XB here? XB is 3 and 2, that is this 3 and this 2. So this 3 is belongs to S1, this 2 is belongs to S2. What is X1 here? So X1 is nothing but 3, 2, 1, 1, 0. This is 0, 1. This is identity matrix here. So next comes 2, 1, 2. Fine. So here comes Zj, fine, and this is Zj minus Cj. So once the values are being inserted here, find out the value of Zj. How to find the value of Zj here? It is nothing but this into this plus this into this. That is 2 into 0 plus 3 into 0. The answer is 0. And here it is 2 into 0 and 3 into 0. Answer is 0. Fine. This is 0. This is 0. This is 0. And this is 0. Fine. Now Zj is how much? 0. Zj is how much? 0. Then 0 minus 1 is minus 1. Then 0 minus 1 is again minus 1 here. Here it comes 0 into 2. That is 0. That is 0 minus 3 is 0. 0 minus 0. 0 minus 0. The answer is this. Fine. So we have to select the most negative among the Zj minus Cj such that it becomes an entering variable. Fine. So let me write here, since Zj minus Cj is less than 0, so choose most negative among them. Therefore x3, let me write, therefore x3 enters the basis. So let me mark the error. So find minimum of xb upon x3, that is equal to. So what is minimum? So xb upon x3 means that is 3 upon 1 followed by 3 upon 2 followed by 0. Fine? Followed by 0. Is it 3 upon 2? No, it is 2 upon 2. Fine? This is that is it. You need not to write. So 3 upon 1 is how much? 3. 2 upon 2 is 1. So let me write here 3 upon 1 comma 2 upon 2, that is 1, that is S2 leaves the basis. So intersection of this becomes key column and this is key row. So intersection of key column and key row will give you key element. Fine? So this is key element. So this table is done. So we need to go for the next table unless and until we get all Zj minus Cj greater than or equal to 0. Fine? That will be explained in the next